Okay, in this video, we're going to be talking about empirical formula. The objective of today's class is to explain what an empirical formula is and calculate the empirical formula of a compound when given the mass of each element. So, what is the empirical formula? The empirical formula is the simplest mole ratio of a chemical compound. So, for example, C6H12 is a molecular formula. Notice we have 6 carbons and 12 hydrogen atoms. The empirical formula is the simplest mole ratio of a chemical compound. So we have 6 moles of carbon for every 12 moles of hydrogen. So that we have this ratio of 6 to 12. Well, we can simplify this by thinking about what is the greatest common factor. Both 6 and 12 can be divided by 6. 6 divided by 6 is 1, so we would have 1 carbon, and 12 divided by 6 is 2, and 2 hydrogen. So for every 1 mole of carbon, we have 2 moles of hydrogen. So that would be the empirical formula. We can simplify C6H12 by dividing both subscripts by 6 and getting the empirical formula. Here's another example, H2O. We have a ratio of 2 hydrogen for every 1 oxygen. Notice we can't divide 2 and 1 by anything to simplify it. So our empirical formula in this case would be exactly the same as our molecular formula, H2O, because it cannot be simplified. And the next example is H2O2. Here we have a 2 to 2 ratio. 2 and 2 can both be divided by 2, so we could simplify this to just HO, make this a 1 to 1 ratio. And lastly, we have C9H15F6. So we have 9, 15, and 6. All of these numbers can be divided by 3. So we can change this to C3. 9 divided by 3 is 3. H5, 15 divided by 3 is 5. And F2, 6 divided by 3 is 2. So we can simplify C9H15F6 to C3H5F2. And lastly, we have SO2H4. So notice we have 1 sulfur. Sorry about that. Okay, notice we have 1 sulfur for every 2 hydrogen for every 2 oxygen for every 4 hydrogen. So we have a 1 to 2 to 4 ratio. So that cannot be simplified. We can't divide 1, 2, and 4 by any of the same numbers. So even though you could divide 2 and 4 by the same number, we can't divide the sulfur, the 1 sulfur, by anything. So this is already the empirical formula. Okay, so go ahead and pause the video and answer questions 1 through 5 on the practice worksheet. Now we're going to try and determine the empirical formula. Again, the empirical formula is the simplest mole ratio. So, for example, what's the empirical formula of a compound composed of 0.4 moles hydrogen and 0.2 moles of oxygen? So we are looking for the simplest ratio. So a 0.4 moles of hydrogen to 0.2 moles of oxygen. In order to find the simplest ratio, we're going to divide by a smaller number. So 0.4 divided by 0.2 would give us 2 moles of hydrogen, and 0.2 divided by 0.2 would give us 1 mole of oxygen. So our empirical formula would be H2O. We have twice as much hydrogen, twice as many moles of hydrogen as we do oxygen. The second example says, what is the empirical formula of a compound composed of 1.28 moles of carbon, 1.29 moles of oxygen, and 1.92 moles of hydrogen? So we're going to divide all these numbers by the smallest amount of moles again. So we have 1.28 is our smallest number. So now I'm going to divide each of these. So 1.28 divided by 1.28, this would equal 1. 1.29 divided by 1.28 is equal to 1.0078125. And I can round this to 1. That's very close to 1. And so we round to the whole number because we need a whole number ratio. And then 1.92 divided by 1.28 is equal to 1.5. Well, 1.5 is right in between 1 and 2. So we don't want to round it because that would give too much error because it's really right in between two different numbers. So what we're going to do is we're going to multiply this by 2. If we multiply 1.5 by 2, we get a whole number. We get 3. But what we do to one, we have to do to the other. So we're going to multiply each of these by 2. And so now we're going to have 2 moles of carbon, 2 moles of oxygen, and we'll have 3 moles of hydrogen. So that is our empirical formula. So our key takeaway is in order to determine the empirical formula, you must divide by the lowest number of moles. So that's really key. Okay, we're always going to be dividing by the lowest number of moles. So now it's your turn. Please pause the video and answer questions 6 through 8 on the practice worksheet. Okay, we're going to determine the empirical formula using grams this time. So again, the empirical formula is the simplest mole ratio. When given grams, you must convert grams into moles. So remember, whenever we convert grams into moles, you should be thinking molar mass. We use the molar mass from the periodic table to convert from grams to moles. Then you can find the simplest mole ratio, just like we did on the previous page, right? We divide by the lowest number of moles to find that ratio. So example 1, what is the empirical formula of a compound composed of 26.4 grams carbon, 3.3 grams of hydrogen, and 70.3 grams of oxygen? So our first step is to convert into moles, grams into moles. So I'm going to take 26.4 grams of carbon, and I'm going to convert it into moles. So moles has to go on top, grams of carbon will go on bottom. I know that for every 1 mole, there's 12.01 grams of carbon. That's directly from the periodic table. That's the molar mass of carbon. So 26.4 divided by 12.01 is 2.198. So that's how many moles of carbon I have. Then I have 3.3 grams of hydrogen. And again, I need to convert that into moles of hydrogen. So I'm going to divide by the molar mass of hydrogen, which is 1.008 grams of hydrogen. That's how many grams of hydrogen are in each mole. So I'm doing 3.3 divided by 1.008, and that gives me 3.2738 moles of hydrogen. Notice I'm not really rounding. The goal is to get whole numbers at the end, so we can round at the end. So lastly, I have 70.3 grams of oxygen. And again, I'm going to convert from grams of oxygen into moles of oxygen by dividing by my molar mass. So 70.3 divided by 16, that 16 comes from the periodic table, is 4.39375 moles of oxygen. So now I have my moles. So now I'm going to do what I did on the previous slide. I'm going to divide by my lowest number of moles in order to get my simplest ratio. So 2.198 is my lowest number of moles. So I'll divide each of my numbers by 2.198. Okay, so obviously 2.198 divided by 2.198 gives me 1 mole of carbon. 3.2738 divided by my 2.198 gives me 1.5, about, it's not exactly, but about 1.5 moles of hydrogen. And then my 4.39, etc., divided by my 2.198 gives me like 1.99, so about 2 moles of oxygen. So now I have 1 mole of carbon for every 1.5 moles of hydrogen for every 2 moles of oxygen. So I still don't have whole numbers. Remember, whenever you have a 0.5 or something very close to a 0.5, you have to multiply everything by 2. And so what I end up with is 2 moles of carbon for every 3 moles of hydrogen for every 2 moles of oxygen. So my empirical formula would be C2H3O2. So in my second example, I'm asked for the empirical formula of a compound composed of 20.2% sodium, 37.6% sulfur, and 42.2% oxygen. So this time I'm given percentages, which we haven't talked about. All you need to do is cross off the percentage and write grams, okay? Because this is like if we had 100 grams, that would mean we have 20.2 grams, right? 20.2% of 100 is 20.2. And so we can pretend that we have 100 grams of our compound and convert from percentage to grams. So then I'm going to do exactly the same thing. So I'll convert my grams of sodium into moles of sodium by dividing by the molar mass of sodium. I'll convert my grams of sulfur into moles of sulfur by dividing by my molar mass of sulfur. And I'm going to do my oxygen up here just because I'm running out of space. I'll convert my grams of oxygen into moles of oxygen by dividing by the molar mass of oxygen. And so I get 42.2 divided by 16 is 2.6375. 20.2 divided by 22.99 is 0.8786. And 37.6 divided by 32.06 is 1.1728. So my lowest number of moles is 0.8786. So I'm going to divide everything by 0.8786. So that would equal 1. And this would equal 3. So I have 3 moles of oxygen, 1 mole of sodium, and then 37.6 divided by 32.06. Oops, I'm sorry. And then my 1.17 divided by my 0.8786 would give me 1.33. Okay. So in your problems, you won't ever have a 0.33, but to get rid of the 0.33, we are going to just multiply everything by 3. 0.33 is like a third, so to make it into a whole number, we have to multiply by 3. So our formula would be Na3 S4 and O9 would be our empirical formula. Okay, so now it's your turn. Please pause the video and answer questions 9 through 13 on the practice worksheet. And here are some answers to the problems. I'm really looking for your work for questions 6 and below. So make sure you show work and then you can check your answers with this. And I hope you have a wonderful day.